The parts library in LTspice contains thousands of components, but there are many more parts in existence. In this video, I will demonstrate a couple of methods for including what are referred to as third-party models in LTspice schematics and simulations. Spice models are mathematical models of components that are derived from the physics of a particular device. They're used to predict the behavior of a component when it is used in a physical circuit. In Spice, there are two basic modeling statements. The dot model statement is used for individual devices. There is also a dot subcircuit statement that is used to define more complex devices like operational amplifiers. These generally contain multiple dot model statements of basic components within them and describe how those individual components are connected. I will go over two ways to include a third-party model. There are other ways, but this will be enough to get you started. First, I will use the operational amplifier circuit from the previous video and change to an operational amplifier that is not included in the default library. Later, I will use a dot model statement to include a MOSFET that is not in the default library. I will start by opening the operational amplifier circuit from the previous video. Currently, the device in the circuit is an op27. To change the operational amplifier, I will need to delete the existing part and add a generic operational amplifier. To delete the existing part, I will use the Delete tool from the toolbar. Click on the X, and then click on the op-amp. Then from the component menu, I will choose the op-amp2 model because it includes the power supply terminals. Click on Place and drop the new op-amp into the circuit where the op27 used to be. I am going to change to the TLV9302 operational amplifier from Texas Instruments. I went to the TI website and downloaded the TLV9302.lib file. This library file contains the models and subcircuits necessary to model the TLV9302. The file can be stored anywhere, but the entire path to the library will need to be in the .library statement, so I'll put the file in a directory called Spice Files on the C drive. There are two text tools in the toolbar. The T tool can be used to place text on the schematic. Text placed with this tool will serve as a comment on the schematic and will not affect the schematic or simulation. The .T is used to place directives. I will zoom out once using Shift-Z to create room for the directive statement. To include the library file, I will use a .library statement followed by the path to the library file, with the path being enclosed with quotation marks. A simple way to do this is to find the file using File Explorer in Windows. Right-click on the library file and select Copy as Path. I can then paste the path into the dialog box in LTspice. Type .lib and use Ctrl-V to paste the path. Place the .library statement by clicking OK, and then place the directive. To make sure I have the correct component name, I will open the library file in Notepad. There is a lot of text present, and it looks quite complicated. All of the asterisk statements are just comments. What I want to find is the first dot subcircuit statement. This will tell me what the top-level model is named. The dot subcircuit statement is followed by the name of the model and then the 5 pins that are used in the model. I will copy the name using Ctrl-C and then go back to the schematic. Changing the op-amp2 model name to TLV9302 will cause the simulator to use the model from the file. The .trans statement is active, so I will run the simulation. After clicking on the input and output nodes, the waveforms show that the model is working correctly. I have an inverting operational amplifier with a gain of 10 volts per volt. To demonstrate the .model statement, I will use a MOSFET H-bridge circuit. The device I am going to use is the BS170 MOSFET that is made by several manufacturers. An internet search for the BS170 Spice model will find a model for the device. I will start by placing a transistor. I will use a generic NMOS component to start. After placing the transistor, I will place 4 resistors using the keyboard command R and Ctrl-R to rotate parts if needed. I will also need a voltage supply and a ground. Pressing V will get a voltage supply. Pressing G will get a ground. I will then make all the necessary connections using the wire command by pressing W. Remember that clicking on a terminal starts wiring. Clicking on a wire while it is being placed will change the direction of the wire, and clicking on the terminal to connect to ends a wire. Continue until all the wires are placed as shown. Pressing Escape ends the wiring mode. I will then right-click on the undefined component values to give them values. Set R1 to 50 kiloohms by right-clicking on the R and entering 50K. Set R2 to 68K, R3 to 1K, and set R4 to 1K. Set the voltage supply to 10 volts by right-clicking on the V and entering 10. I will then copy the text of the model statement I'm using and use the .t tool to put the .model statement on the schematic. As a note, some model statements can get quite long. In order to fit the model statement on the schematic, I used multiple lines. The plus sign at the beginning of the second and third line tells Spice that those lines are part of the same .model statement. The final step to get the simulator to use the model statement is to change the NMOS label to the name of the model. In this case, BS170P. Spice is not case sensitive, but I capitalized the model name for aesthetic purposes. To check the function of the model, I will use a .op statement to do an operating point or DC analysis. After placing the .op statement in the schematic, clicking on the green Run button will result in the DC operating point being simulated. A dialog pops up with all of the voltages and currents in the circuit. We now have two ways to include third-party components in our schematics and simulations. I hope this is helpful for you. That's all for today. Go out and make it a great one.